I'm Isaac Asimov. You've seen me in such great, purposeful, epic physics videos such as robotics and physics vectors. What's the connection? And I sing the body electricity. Okay. So for this, guys, we're looking here at a worksheet that I passed out. Chapter 6 Force Problems worksheet, where I gave a bunch of formulas here, but I just want to get straight to the problems. So we got here an example, two guys pulling on an elephant. Guy 1 pulls west with a force of 500 newtons. Guy 2 pulls also west with a force of 300 newtons. So what's the total force that's exerted on the elephant? The net force. Now keep in mind that there are forces that can be opposites of each other. And what happens is that will cancel out until one force, if one force is bigger than the other, then there's going to be movement. And in this case here, if we just quickly draw an elephant, but you have one force here with 300 newtons, you have another one here with 500 newtons. Now since they are pulling in the same direction, it's a safe bet to say we can add them together, and what we end up having is the net force exerted on the elephant is 800 newtons, which is the result of 500 newtons plus 300 newtons. Okay? Very straightforward. Now let's look. We're going to have the same situation where we have guy 1 pulling west with a force of 500 newtons. Okay, on the other hand, if you have guy 2 pulling east with a force of 300 newtons. So now we got a situation where we have one going west with 500 newtons, then we have one going east with 300 newtons. Now you could argue, hey, this is like a tug of war. What's the net force acting on it? Well, in this case, you got to determine which one is going to be the direction. Okay, so one of these is going to be a negative number. And the reason why, because we have to indicate which way is the negative way. Now, typically, we go this way to indicate a negative number. If it's west of the 0 point, going this way is positive. It doesn't matter, because ultimately what's going to happen, you are going to have 500 minus 300, or you could say 300 minus 500. So what's the net force exerted on the elephant? It's going to be 200 newtons, and then you are going west. That's ultimately the final answer, because 500 minus 300 gets us 200. And then direction is important. It's going west. So that's it for these two problems here. We got a couple more where that's going to involve a little bit more time on it. So let's go ahead and let's get it to it. So we got a problem like this where Brian is riding on an elephant standing on slippery grass. The elephant with Brian on it has a mass of 1,500 kilograms. Okay, so there's a piece of information I need. The elephant is being pulled by Ray and Roy. Ray tugs on the elephant with a force of 1,500 newtons north. Roy tugs on the elephant with a force of 2,300 newtons east. Friction does not exist. So they're asking us, what is the resulting force on Brian and the elephant? Okay, and then what direction will Brian and the elephant be pulled in terms of degrees and direction? Well, it's always good to go and draw a diagram. And in this case here, I'm just going to draw a little box here, and I have got one vector, 1,500 newtons to the north, and then I got another one that is 2,300 newtons to the east. All right, now, if we were to go and look at these vectors, what's going to be, if we were to add these vectors together, what would our resultant vector be? Where would it be going? Well, remember earlier we talked about the idea that you could transfer the vector head to tail, head to tail. So I'm going to take this vector and I'm going to put it over here, okay? And I'll make this one a nice red vector, okay? So I took this and I brought it over here, head to tail, okay? So now, what does that mean for us? Well, we still have our 1,500 newtons. That does not change. Okay? But we do get a resulting vector. And that resulting vector is right here. This is our resulting vector. This is the vector that the elephant is being pulled in. Because remember, you've got two forces that are acting on it. One going north, one going east. How do we find the resulting force? Well, for this one, you may notice that we have the two legs of our right triangle. We're missing our hypotenuse, our resultant vector. And that's where the formula a squared plus b squared equals c squared comes into play, justifying what this is. Okay, so let's go with it. It doesn't matter which side is A or B. It doesn't matter. So I got 1,500 squared, because I'm going to square this side, okay, plus 2,300 squared. And notice I kept the colors the same so you can see where I'm going with it. And that's going to equal our c squared. So I got to take a calculator and I got to punch this in. Okay, so 1,500 squared plus 2,300 squared equals, and I got a giant number. My giant number is 754, and then 4 zeros following it. Okay, so 7,540,000. That is our c squared. Is that our answer? No, because what we got to do, we have to take the square root of this. Now, okay, and the square root of our answer, and, oops, hang on a second, I got to go back, let's see. Square root of 754, and then 1, 2, 3, 4 zeros. All right, so I'm going to erase all this, okay, so I can give you guys the final answer. Okay, if you got to go back, you can rewind this, remember. Okay, the videos here, at this point, they are ad-free. Okay, it's meant for everybody. So our C is equal to 2745.91 newtons. That is our answer to A. What is the resulting force on Brian and the elephant? It's 2,745.91 newtons. Now, if I want to look at significant figures, okay, if you guys notice here, you could argue that, oh, there's two significant figures. It's fine if you said 2,746. I'm okay with that. Now, the second question, and this is one that's a little bit more tricky. What direction will Brian and the elephant be pulled in? This is in terms of degrees and direction. This is where we're going to have to use some trigonometry. We now know what this is. We know this is 2745.91. So I need to draw that. Notice I'm keeping my triangle there. I need to find what is the direction, okay? And that means how many degrees and where is it going? Well, that means, well, what angle are we looking for? This is our right triangle here. This is our hypotenuse. The angle that we're going to be looking for is this one right here. That's our angle that we're looking for. You'd say, but wait a minute. Couldn't we look for this angle here? You could, but it's better to do it this way because you already know the pieces that are there and you have no problem with it. Okay? So with that, we can look at, well, what's the direction? Well, if you know that this is east and this is north, okay? Looking at this, we start at the east as our 0 point. When we move our vector up, we're going toward the north, right? So we're going north of east. We started at the east and we're moving north. That's why we can say north of east. So that's half of our problem right there, north of east. The problem comes down to is, how do we figure out the degrees? This is where we're going to have to take the inverse, okay? The inverse of our trig function. So, if we remember here, there's some pieces, there's some things that we need to look at. We know that this is our adjacent This is our hypotenuse, and this is our opposite with regards to this angle here. That's the key. This is the angle we're looking for. This is our hypotenuse. That's fixed. This is our adjacent. This is our opposite. Now, you can choose which way to go. You could use sine or cosine. Wow, you could even use tangent if you want. I'm going to go with cosine because it takes the adjacent right here and the hypotenuse. Okay, so, well, wait, what's the cosine here? Well, our cosine is adjacent over hypotenuse, right? So our cosine of theta is equal to the adjacent over the hypotenuse, so that's 2300 over 2745.91. So this is what we have. So if we go and divide it, 2300 divided by 2745.91, and I have 0.8376. So my cosine of theta is equal to 0.8376. Cool. Because we took our adjacent divided by the hypotenuse, we got the value of the cosine of theta. But we're not done because we got to find out what is our theta. That's when we have to take the inverse cosine. In order to find our theta, we need to take the inverse cosine of this. Okay? So when you go to the calculator, now, we can turn around and take the inverse cosine. So I'm going to shift. So now I have the inverse cosine. I'm going to put in the answer here. And I press the equal sign, and I go away with 33.11 degrees. So our final answer, it would be 33.11 degrees north of east. That answers the second question here. We figured out the north of east here. This is going east. This is going north of east. And then here, our theta, it's cosine, inverse cosine of 0.8376, which we found here with our adjacent over hypotenuse. And we walk away with 33.11 degrees north of east with that. Okay, well, I got to check on my timing because I don't get to see that. 12:50. I'm kind of debating. Do I start another episode with another guest? Perhaps. And I think I'm going to go along the lines of I'm going to go and start another video to work with the problem here on the back, because that's going to be a little bit more involved with that. Okay? So this is it right here. All right, and I'm going to shrink that a little bit. Okay. So we're going to take a look at this in our next video. So hit like and subscribe. I'm Isaac Asimov, and I'm here trying to teach you physics. Take care. God bless. Have a good day.